Okay, so in algebra we're in section 2 of chapter 9. We're going to multiply polynomials today. Okay, so we're going to start by multiplying a 4-term polynomial, as you can see in parentheses here, with a monomial, just a single term. So what do you think you'll do? What comes to mind when you see 3x squared outside of parentheses? Excellent. Jocelyn says distributive property, right? So we might draw in our arches so we make sure we account for every term. We're going to multiply 3x squared by each of the 4 terms, right? And may you multiply unlike terms together?
Yes.
Yes. I can multiply 2 times x and get 2x. So we don't have the same issue we did with addition and subtraction, where they have to have the same variable to the same degree. You know what I'm saying? That makes it trickier. This is pretty straightforward. So when we multiply 3x squared times 2x cubed, what do we get? 3 times 2 is 6. And x squared times x cubed is x to the 5th, right? I have 2 x's here and I have 3 x's here. So if you were to expand that, I have 5 x's all multiplied together. So there you go. Minus, we have 3x squared times x squared. That would be what, Michael?
3x to the 4th.
Good, 3x to the 4th. Plus, we have 3x squared times 4x. And what would that be? Jack? Okay. He says 12, good, 12x to the 3rd. And then minus, we have 3 times 3x squared, which is 9 and an x, right? X squared. Okay, because this first term is a squared term. Okay, so what degree is the new polynomial? The degree of the new polynomial is 5th degree, right? We look at the leading or the highest degree term, which this is in standard form. This has the highest degree term first, the next highest, the next highest, the next highest. That is standard form, okay? Starting with the highest degree, and we would call it a 5th degree 4-term polynomial, okay? Is there any term that could be combined with another term here? Are there any like terms here?
Yes.
Where do you think there are like terms? This is a third, 12x to the 3rd, and this is 9x squared. So they're not like terms. This is like having an iPad Shuffle, a Nano, iTouch, and an iPad, right? They all have something in common. They're all made by Apple, or they all have an X, right? But they're different kinds of things, so they may not be combined. I kind of like that analogy. Okay, so go ahead and try this, and we'll see if we agree on your answer. And when you get the answer, whatever your new expression is, can you identify it by number of terms and by degree, please? Okay, Archer, what do you have?
I've got 7x cubed plus 4x.
Good. And so identify this by degree and number of terms.
Is it the 3rd degree?
3rd degree, what?
Polynomial.
It's a polynomial, and classified by number of terms. 2 terms, so we say 3rd degree.
Binomial.
Good. Binomial. This is by looking at the exponents, and then this is the number of terms. Good. Okay, let's multiply 2 binomials. So we have x plus 4 times 2x minus 1. So one way we could do that, draw yourself a little table. And in this way we can show that each term in each binomial ends up multiplying to each term in the other. So in other words, x is going to multiply to 2x. X times 2x is 2 what? Tara? X times 2x is 2x. Good. And what about x times the negative 1? What is that? What is it, Dina? negative x. Good. And now we're going to move to the 4, right? 4 times the 2x is, anyone? 8x. And 4 times negative 1 is negative 4. So binomial times a binomial is commonly used in area problems, so which is why we do algebra before we do geometry. You might even end up with bigger things than binomials. Are there any like terms among the 4 terms we have here, JD?
8x and negative.
Good. So we'll combine those and we end up with how many x's?
7.
So our simplified expression is 2x squared plus 7x minus 4. And who could classify this by number of terms and degree? Michael?
Is it a second degree trinomial?
Good job. Second degree and trinomial. Good. Oh yeah?
I don't really.
Okay, once we get to more involved multiplication of polynomials like this, we have a trinomial and a binomial. We can continue with multiplying horizontally, if you like. You could also multiply vertically. So we want to try this method because if you end up with really long factors, and remember, these are each factors. This is a giant factor. 3 terms multiplied to 2 terms, but they're factors because it's all multiplication, right? So when you have a long polynomial multiplied by another long one, it may be easier to stack them vertically. So that's what we'll try right here. Okay, so I'm going to take the second term, 2a plus 3, and put it beneath the first term. And this is just like multiplication of numbers with digits, right? The difference is there's no carrying typically because we have unlike terms. And so you don't have that carrying that we do. But we're going to multiply each of the terms in the trinomial to 3 first, and then we'll multiply them each to 2a. So, Dina, you want to tell me what negative 4 times 3 is?
Negative 12.
Negative 12. And then what is 3a times 3?
9a.
9a. And then a squared times 3?
3a.
3a squared. The 9a is positive, so I'm going to show the sign. Because there was another term there, so I need to show the sign. Now we move to the 2a. I'm going to start with negative 4 times 2a. What is that? Negative 4 times 2a? Negative 8a. And I'm going to put it underneath its like term. Okay? And we have 3a times 2a, which is?
6a squared.
Good. 6a squared underneath its like term. And then a squared times 2a is 2a, good, to the third. And I'll put the plus sign in front of the 6a because it's a positive term, and now something else is in front of it. So we don't have to put a plus sign in front of the 2a cubed because it is leading the way. So we know it's positive, right? So we just allow it to be 2a cubed. If there was something more to the left of it, we probably would put a plus sign there. Now we simply combine our like terms. So we're so used to starting in the ones place, right? That we might start over here and say negative 12 plus nothing is negative 12. 9a plus negative 8a is just a 1a, and it's positive. So 3a squared plus 6a squared, and then we have our 2a cubed. We could have actually started from the left because you see we have no carrying, do we? Because these are like terms that must be combined. Okay? So when you're doing your assignment today, try vertical multiplication, and then, of course, you'll be doing some horizontal multiplication too. So it would be a third degree 4-term polynomial. Okay, good. Let's try this one horizontally. Okay. So we have a trinomial times a binomial. So how would you do that? You just what? You just do it. So you might, I like to, you know, everyone has their preference, but You could leave it exactly as it is and just say, I'm going to distribute the 3x to each term. 1, 2, 3, right? And then you'll do the same with a -1 after doing this multiplication. You might be more comfortable taking the binomial and putting it over here, right? 3x minus 1. We're so used to going left to right with our distributive property that you could move things if you wanted to. What allows you to move 3x minus 1? Which property? Commutative property of multiplication. It is a giant factor. You could move it. But just because it's more challenging, we'll leave it this way. 3x times 2x squared. 3x times 2x squared. Good. 3x times negative x. Negative 3x squared, right? 3x times -2. Negative 6x. Keep your sign with you. Okay? -1 times 2x squared is. I'm going to go ahead and put it under its like term. -1 times negative x. Positive 1x, right? -1 times -2. Positive 2. Okay? So we could go ahead and combine like terms. How many x squares do we have?
-5.
Good, -5x squared. How many x's?
-5.
And then plus 2. You see how I added them left to right this time? Because carrying is not an issue here. So I just combined like terms. And who can identify this by, classify it, the two ways we've been doing it? Can you, Kelly?
Yeah. It's a third degree and it's a 4-term binomial.
Four-term polynomial.
Oh, sorry.
If you say four-term binomial, that's kind of contradictory. 4-term, 2-term, right? Okay, go ahead and why don't you try multiplying one of these vertically and one of these horizontally and come back and check your answer. Okay, if you need to pause the video so that you can see these, this looks correct. 13y minus 15. Good. Okay, so we commonly end up with a binomial times a binomial. And so we've already talked a little bit about this even in 7th grade. I mentioned the term that we use. In some of the high school test prep, I mentioned the term that we use. But who remembers the strategy for multiplying two binomials? There's a little acronym that we use. Do you remember the acronym? Anybody? Lauren, say it loud. FOIL. Okay? And that's because we multiply the first terms together and then the outside terms. So these two terms are considered the outside of the pair of binomials, right? And then we do the inside terms that are closest and the two last terms. So the acronym that we use for multiplying two binomials is FOIL. Okay? So the first terms, 4a times a equals 4a squared. Outside terms give us 8a. Inside terms give us 3a. And last terms give us 6. The outside, inside often combine to give us, they're like terms, so we can call that 11a plus 6. So when you're foiling, outside, inside often combine. We have to be strong with our multiplication because what's coming after multiplication is the inverse operation. What's the inverse of multiplying? Dividing. It's factoring, dividing. And so we're going there next. So we got to be really comfortable with foiling these things so that we can later say, oh yeah, I remember foiling it, and now we take it and we get back to the factors. Okay? So let's go ahead and pause the video, try these, and come back and check your work. Okay, so I hope you notice that when both binomials have addition, we add the middle terms. When we have a subtraction binomial and an addition binomial, we subtract the middle terms. And the final example is both subtraction. So pause and come back. Okay, so here we have two negative terms, outside, inside, and we add them because they're both negative and get a bigger negative. Notice the last term is also positive. Okay, that's important. Okay, so when you have a rectangle with binomial dimensions, you're going to end up foiling. That's the point in this one. So here is your assignment for today.